thing before I say anything. All right, so recording has been started. All right, are you able to hear me clearly, everyone? You can answer to me using the questions window. Hi Bashwant, hi Samip, hi Pavan, hi Anuj, hi Karnabiran, hi Prateek, hi Vishwaro, hi Anuj. All right, so hi Akash and Prateek. All right, so great to have you all in the session. So please feel free to introduce yourself because that will help me a lot in understanding the audience. So today we have a great session and we have around 30 people in the session because it's a first beginning session which is open to larger audience. Great. All right. So first of all, welcome to the Big Data and Hadoop introductory session. So feel free to introduce yourself using the questions window while others are joining the session. Yes, Hari Krishna, you have a question? All right. Hi Prateek, hi Rahul, hi Shayak, hi Naveen, hello Swapnil and Ravichandran, Srinidhi and Patrick. I'm sorry, my name is shown as uh, how does it show? All right. Ouch. It shows my name is Sharon because Sharon is the one who created the webinar. And all right. So I'm Sandeep Giri, although it shows Sharon. Great. Yes, I'm Sandeep Giri. All right. Great. Great. So, yes, good to know about you, Anuj. Patrick's point is that how to see other people's question. The problem right now we have is in this go to webinar, you can't see other people's question, and that's a little problem. But in next sessions from second onwards, we are going to use go to meeting. In that, you can see the questions from everyone. All right. A lot of great questions coming and all right. Okay, so we have Anuj in the session. Anuj is working as business analytics as of now, and his main expectation is to get into Hadoop admin or development. Great. So this course, which this class is the first of the course, and the course focuses on Hadoop development part. We have Josephine in the session, and all right. So hello, Pankaj, and hi, Patrick. All right, Pankaj is from Bangalore. Tracy is from Chicago. Hi, Tracy. Great to have you in session. And we have Prashant. Prashant's question is, how big data is different from our database? All right. So you will get to know as we go ahead. So it'll be a little immature to answer it now. But remind me if this question does not get answered by end of the session. Question from Anuj is, I have some development experience in Encompass LOS system and was working with system admin dev for this application. Great, great. So yes, for you, I think this course is going to be good for Hadoop development. All right, we have Naveen. Naveen is Oracle Core DBA with 3 years of experience. Good to you have you in the session, Naveen. We have Vikas Kulkarni, and Vikas is working for EMC and would like to venture into big data world. Great, great. So this course is going to be quite exhaustive, and you're going to see more of, almost all the tools under the umbrella of big data. You will get the hands-on experience on almost all the tools. All right. So we have Kanan. Kanan is working as QA lead and have 10 plus years of experience. Great, great to know you, Kanan. Wow, we have great set of audience. All right. We have Hari. Hari has planned to get into Hadoop. Great. We have Naveen from Bangalore. Raul is also from Chicago. Great, great to have you in class, Raul. And we have so Kanan is from Texas and looking for big data admin and development. Great. This course will be focused greatly on development, although we will guide you on admin part a bit. All right. We have Ravindra. Ravindra is working as ETL admin architect developer. Good. And we have Prasant. Prasant's question is, are companies currently utilizing big data in V2V, V2E, autonomous driving segment? It depends on the companies. It depends on individual companies, but every company as of today is trying to utilize data and trying to figure out how they can get more and more data recorded. Josephine's question is, Ruby and Rails is useful for big data. So for big data, you can let me answer it a little while later because it's not a straightforward answer. So a question from Raul. I have data warehousing experience as ETL developer for 3 years. Great. And all right. So Pratik is saying, are you on mute? So actually everybody except for me is in mute. All right. There are few more questions from the attendees. So we have Samip. Samip is working as QA analyst at Dallas, Texas, and he's planning to change my career to Hadoop. Great, great, Samip. So you should be able to change the career with a little bit of this course and a little bit more effort. We have Ravi Chandran from Intel Bangalore and working as data warehouse project for last 8 years as technical PM cum solution architect, and he has total 18 years of experience. Great to have you in the course, Ravi Chandran. Great. So that's something different about our courses. Most of our courses you will find most of our students, you will find people with a great background. All right, we have had people from NASA in my course, and we have had people from um, the senior architects from Amazon. So, all right, we have Pankaj. Pankaj is working on IoT development. So I'm joining this meeting with perspective. How could I use Hadoop for IoT applications? All right. So his question is that he wants to see how he can use Hadoop in IoT applications, and he wants to see if that's discussed in the session. So if your question does not get answered in today's session, we can have another one-on-one, Pankaj. All right, and we have Babu Venkatesh from Applied Micro Circuit Corporation, Bangalore. Great to have you, Babu, in the class. And hi, Ajay. Okay, so Kanan's question is, how is the job market for Hadoop in USA? I'll throw a little bit light on that part. But I would say that a better answer can be given by a site like indeed.com. Indeed.com. All right. And I'll try to answer it as we go. We have Gizi Korean from Florida, and he's a .NET C# developer. Good. We have Pradeep from Bangalore, who is working as developer, and he wants to learn Hadoop. Kavita says Kavita is new to big data, and I am a Six Sigma black belt. Great to know you, Kavita. So we have Pavan. Pavan is a technical architect and is looking forward to get in-depth knowledge of Hadoop. Great, great. So this course would be good for you, Pavan, and I'm sure you will gain entire understanding of the ecosystem of Hadoop. We have Tracy. Tracy works for CME Group, and the team has merged with another team that owns several Hadoop clusters. I'm here to learn what I need to support my team's cluster and application. Good, good, Tracy. All right, and okay, we have Akash. Akash is having C#, .NET, and SQL Server with 1 year of experience, and is looking for career in big data and Hadoop. All right, now. So Ajay's question is how much hands-on would be going forward on the daily basis. So most of our sessions are very much hands-on. So anything we discuss, there has to be following hands-on every topic. Okay, so be ready for that. Except for today's session. Today's session is mostly theory. I mean general ideas. And from second session onwards, we are going to do a lot of hands-on. All right, we have Prudveer. Prudveer is a Java developer interested in big data. And all right, good. Anu's question is, will you be able to adjust time of the course or may skip couple of week based on my project go live schedule? Okay, so every session is recorded and would be available in LMS. In case you have to skip, the session is available in the pre-recorded format. Ketan is saying that which framework should be preferred for Big Data Hadoop or Spark? Which framework should be preferred for Big Data Hadoop or Spark? Both have their own use cases. We will be discussing both. In this session, this course, we'll be discussing both Hadoop and Spark, MapReduce and Spark. With MapReduce Spark, we are going to spend entire 3 hours with hands-on and details. We have Nand Kumar. Nand Kumar's question is, I am Nand Kumar, having 17 years of experience, and I am from database background, but no experience in big data and related tools. I'm interested in big data related careers. So this course would be good for you, Nand Kumar. All right, so let's start it with today's session. Okay, we have Hemant who is working on Spark. Great to have everybody eh, in the session. All right, those were introductions of everyone in the class, and it was it was a great it was great to know all of you, your backgrounds, and I'm impressed. Okay, so a quick overview. So in this 3 hours duration, in first half, we are going to understand big data, and second half, we are going to discuss the various components of Hadoop architecture. And then in the between, we are going to take 10 minutes break. This session is being recorded, and recording and presentation will be shared. You are free to take a screenshot, or you can also record the screen and feel free to record, but we don't mind. But you don't have to worry because everything is going to be shared with you. And if you have any questions, you can type questions as you have been. Everyone except for myself is muted to avoid the communication collision. And I will read out the questions before answering. So, and also, please keep your messages short, but not so short as SMS or chat language. I'm pretty poor with that. And because the session has many more questions, so so please keep your messages little clear. That makes my life a little easier. So this is the first session of our 12 sessions on big data and Hadoop course. It suffices as an this session suffices as an introduction to big data technology stack. All right. So if you're from sales background, marketing background, or in general, somebody who is in a decision making role and wants to just understand and get an overview about the the technology stack, this session would be useful for you. All right, good. So first of all, welcome to No Big Data. For last 2 years, we have been giving trainings into the big data domain and executing the consulting projects into big data. Also, we have built products like CloudX Lab, which is being used in industry. And also, to everyone, this is an apology from my side that this might be my last course this year. I'm not going to run any more courses for a couple of more months. Okay, so most of my courses will be available as self-paced, so you can take the self-paced one. And this course, which is starting today, is most likely my last course this year. All right. So we have been running No Big Data for 2 years, and the highlights of No Big Data is we have had great set of instructors, and we provide a lab called CloudX Lab, which is being used by the entire industry as of now, and we provide lifetime access to the LMS so that you can have the presentation, class recordings, assignments, and quizzes, everything in a single place. And at the end of the course, we provide you a project. But for real life project, you need to finish and finish the all the assignments and projects provided in the class, because real life project which we provide demands a lot of time commitment and lot of uh, uh, the ownership. Therefore, the criteria we have for real life project is the people who finish all the assignment, quizzes, and project work become eligible for real life project. And at the end of the course, you get a course completion certificate, provided you finish your project. And the whole guidance for how to finish the project, how to do the assignment will be provided by us. So we provide 24 by 7 email based support, although you can call us up. But since calling is little difficult to answer, we prefer the email based support. And and in the beginning, we'll keep a one-on-one so that the support cost is low, so that you get all the answers cleared in the second session itself. Next is that we have some groups, a group on Facebook called Alumni, whereby you will see all this members, all this past student as our members, and we keep on posting jobs, we keep on posting the emails on staying abreast, and we stay connected with our all candidates. All right. So today's topic is understanding big data and Hadoop. This is first of 12 sessions. And also please note that the sessions might go beyond 12 i- if there are more questions, more detailing need to be done. Sometimes in the class we might have to take a Python, a little digression to explain Python, and sometimes we might have to take a digression to explain Linux. So because of that, generally my classes, instead of 12, they go up to 14. All right. So, all right, a little bit about myself. I did my graduation from IT Roorkee in 2002, and then I worked for a company called DE Shaw. The interesting part about DE Shaw was that we built big data systems before even the term was coined. So, as an example, in 2002, when I joined, we were having 10,000 nodes cluster. My data that used to come from New York to Hyderabad, India, since it has to come every week, we could not download the same data in over the week. So instead of downloading the data over the network, the data used to come by via ship or via plane. So effectively, the plane was faster than the electron. If you consider the big data, that was my first introduction to understanding how the data pushes you into changing your conventional ways. As the data grows into big data, your normal laws does not apply in various ways. You will see as we go in this course as well. So that's the whole idea, because when the goes beyond a point, most of your conventional wisdom does not apply. Afterwards, after working for D Shaw, I started a company called T-Bits Global in Hyderabad. We built enterprise-grade document management system and is being used by many organizations. And it was basically large-scale handling of lot of data. Afterwards, I joined a company called InMobi, where since my interest lies in churning data, we build recommender as in which can recommend things to the students based on Hugh's Apache logs. And these logs, this data which we were churning to generate recommendations, were around 200 terabyte. Afterwards, I worked for a company called Amazon, where I worked for 2 years. And we worked on many things. And one of the things which I owned and built was this high throughput system, something like on the lines of Storm, but not as big as Storm, a smaller version of it, specifically for Amazon, so that a huge data can be processed parallelly by many machines in order to generate the images which are displayed on the product detail page. Afterwards, I founded No Big Data and now CloudX Lab. So we're working on CloudX Lab and No Big Data as of now. Although both are same, but they are two different entities. All right. This is what we will learn in today's class. All right. So a quick question from Anil. Are you going to cover Scala in this course? No, we are going to focus on Python with Spark instead of Scala with Spark, because I want to focus on Spark rather than the programming language, right? Because learning Python is far more quicker than Scala. That thereby we are going to focus more on Python with Spark. And we have another question from Jason, who doesn't have programming concept. Is this course suitable for them? If you do not have a programming background or you never did programming, this course is going to be tough for you. So I would not recommend this course for somebody who never had used or built a program. All right. Prashant's question is, and all right. Next question from Prashant is, my understanding is that big data is exploratory in nature and shows what if kind of scenarios. If this is true to an extent, then can the big data technology be used to answer without using parallel computing? And as it's the only application, all right. So you will get your answer by end of session, Prashant. If it doesn't, let's discuss it afterwards. All right. It's a very interesting question. Good. Good. So, what exactly do you understand by big data? Because we are going to discuss big data, and this term is being used in many contexts. So, we would like to have a mutual agreement on the term itself. That's why I want to discuss what do we mean by big data. Yes? Yes? This is a question to all of you. All right. Great set of answers. Great set of answers. Okay. Kavita says large amounts of data, seemingly random. Ajay says big data often can be associated with three V's: velocity, veracity, and volume. Okay. Deals with large amount of data. Good. High amount of data can't be handled by only RDBMS technique. Good. Data which is so big that cannot be easily stored and processed by databases. That's good, Pavan. Okay. This good, Balvinder. So Balvinder is saying no clue. That's why I joined the course. All right, of course. And so the idea of this question is so that we all are on the mutual agreement of the definition. Okay, Subham's question is any data which is huge in size and is distributed across multiple machines. Data not capable of being handled by conventional databases like SQL. Data which cannot be handled using traditional DBMS. Big data is the term depends on brilliant answers. Brilliant answers. All right. All right. So good. So the answer is in very simple words, I'd like to summarize all of your answers. So in very simple words, it's a data of very big size that you cannot process using the conventional tools. Okay, these are the this is the data with which you cannot usually process with the usual tools. What do we mean by usual tools? Usual tools means your normal file system like NDFS or other file system, and the databases like Oracle or MySQL or MySQL, MS SQL, Sybase, Postgres. So this kind of data which you cannot handle with the usual tools and techniques, and whether the data is in the form of structured, as in the form of tabular with predefined schema, or the data which is unstructured. So the most important part in this definition is that you require multiple computers to solve your data related problems. So you would require a distributed architecture to process this kind of data. So, the most important term in this discussion is the distributed architecture. So all the tools around 10, 12 tools which we are going to use in this course, all of them has one common behavior. And what's that common behavior? They all are distributed in nature. Okay. So we're going to talk this distributed computing in a minute. All right. So before that, I'd like to answer Sameep's question, who has asked it a while back. The question is, what level of programming experience uh, is essential, or what level of programming knowledge is essential for the course? For this course, I expect that people know the structure of a program. that a program has variable, you can assign them, and a program can be compiled or can be run as a script, or program has do while loops and the various looping and functional construct. So that's a basic level of programming. We are not talking about algorithms. We just that when we look at piece of code, uh, people should not get blacked out. Although I would explain each and every piece, every line of the code, but if somebody has never done a programming, even in school, then they are going to get blacked out when I show the piece of code. All right. All right. So let me try to answer this further. Okay, so first let me differentiate between structured, semi-structured, and unstructured data. So the data in which we know the schema, as in what are the columns and what are their data types, then we call the data as structured. We know what are the fields, we know the what are the data types of each field, then we call that data very well structured. Now there is on the other extreme is our unstructured data. And what do we mean by unstructured data? Unstructured data is something which, before applying any logic on top of that, we would have to first convert and infer what is inside the data. Say, for example, you are given a plain text file and it has some data in new line format, some data is in tab separated. So uh, it's not really well formatted. It's a plain text file. To to say filter this data, to say organize this data, you would have to first understand the structure and then apply an ETL tool to convert that data into structured before processing it. Semi-structured lies between the two. In case of semi-structure, you neither know what are the fields nor you know what are their data types. Sorry, you know what are the fields, but you don't know what are the data types. That's a semi-structured data. For example, if I give you a CSV file, if I give you a CSV file, you won't be able to figure out instantaneously which column is date time, which column is boolean, which column is string, and which column is, say, integer or decimal. Okay, for this translation of a CSV file into a proper tabular format in which we know the data types of each field, it would require certain amount of intelligence and processing. So that's called semi-structured. So CSV or maybe sometimes XML when we don't know the exact data types is called the semi-structured data. All right. All right. So Pankaj's question is, what are the examples of usual tools? Usual tools as in the tools which have been conventionally using for processing data. Say a database system such as Oracle or MySQL, or a file system. Baswan's question is, sorry if I'm asking too basic question, but what do you mean by distributed architecture? I'm going to explain that now. All right. So when I say distributed, what it means is what it means is we group it's a group of network of computers And these networked computers interact with each other to achieve a common goal. All right? So this is distributed computing. Distributed computing means that there are many computers networked, and you are utilizing all these computers to solve a singular problem. A singular problem could be to find a particular DNA sequence which match a certain mediation, and then a certain signature. So we divide that work and send it to all the computers and get it done. Or it could be as simple as that: you have hundreds of terabytes of data and you want to find a particular string in this hundreds of terabytes of data. So you send your logic to these computers and send the data partially to all these computers and divide and conquer the whole work. So this is distributed computing. It utilizes many computers. It utilizes many computers. All right. There is also one term called parallel computing. Parallel computing was generally used whereby, so what exactly is parallel computing? Parallel computing means you have a single computer, but many processors in the same computer. Single computer with many processors sharing the data through the RAM or through the memory. That was parallel computing. But interestingly, both the fields, distributed computing and parallel computing, are very much on the verge of merging. So because both ideas, as parallel computing and distributed computing, both of the ideas rely on dividing the work. Therefore, the algorithms in both the fields are very, very similar in nature. All right. Now, let me take a few more questions. So, Balvinder, is your question answered related to the example of such data that is unusual? Okay. So I will give that answer. Okay. So his question is that can you give real-time example of such data that is unusual and distributed? Any data related to, imagine, if you imagine even the data that's being handled by Facebook and that's being handled by Google, or even in your organization, wherever you have huge data coming at very fast pace. All right. You will get to know more. All right. Pratik, was I able to answer your question? Satish's question is without Java also is fine. Okay, let me complete the question. Question from Satish is that will this course be okay if you don't know Java? Quick answer is yes. Only one chapter where we discuss MapReduce in Java. That's the only course we are going to discuss Java. Otherwise, everywhere in the course we use a non-Java kind of environments, and you will be comfortable. Also, because MapReduce is a paradigm, it can be done in Java as well as in any programming language. So we'll be showing you how to do MapReduce using shell programming and Python programming along with Java. All right. So Pankaj's question is, when we say distributed computing, does it include devices too? So IoT devices are not considered as part of the distributed computing. IoT devices can be used for distributed computing, but the way it happens is most of these IoT is Internet of Things, whereby every device becomes kind of intelligent and can generate, has sensors and generate data. So So, so IoT devices too can be part of distributed computing. Okay. But since every IoT device to save the power, the CPU ability is quite low, and therefore most of the devices which I've seen so far are usually for transmitting or observing particular data and scenarios in a network. A question from Ajay: would handling of unstructured data be done be one of the differences between SQL NoSQL databases? So, okay, so let me rephrase the question from Ajay. So, question from Ajay is the difference between SQL and NoSQL database is unstructured unstructured data? Not really. The the origin of NoSQL database, I'm taking a little digression here. So be with me to answer the question. So the only for NoSQL was done, invention of NoSQL was done in order to process huge amount of data at a huge speed. Okay, it so happens that at lots of time, when you are dealing with high speed data, it's better to keep it unstructured than rigidly structured. You will see in a session where we go into the details of why NoSQL was in the first place invented. All right. A question from Pankaj is: do we have a Hadoop system run on IoT devices? Very difficult, because as you'll see, Hadoop systems require fair amount of computing. Therefore, it will be unwise to run Hadoop on IoT devices. But it can run, there is no doubt about it. It can run on things like Raspberry Pi, but not below that. It can't run on Arduino because it's in Java mainly, and therefore Java requires at least a fair amount, JVM requires a fair amount of memory, and that would not be provided by Arduino mostly. A question from Pankaj is: what's the minimum configuration requirement to run a Hadoop system? So I hope that I answered that question. So, a question from Anuj. So, data is stored in different computer, or data is stored at one place, and while solving a problem, we divide and send to different computer, or data is actually stored in cluster as well. Very good point, Anuj. Anuj's question is: when we are talking about distributed computing, and when we are talking about solving the problems like data, so his question is this data also stored in these devices, or is this data transferred on every computation? Very brilliant question. So that is one big difference that is brought by Hadoop, because when in case of HDFS, the file system, the data is distributed in the machines, and when you send the computation, you don't send the data because data is already there. Instead, you send the computation to only the machines which contain the data. We will go into more details about this when we discuss yarn and when we discuss MapReduce. All right. Pratik's question is: are you showing an example of unstructured data? Unstructured data is normal Apache log, or things like videos and things like photos. All right. A question from Kanan: big data tools involve more of client-server programming, or it is related to DBMS programming like SQL? So I would say that it doesn't have a client-server kind of models. Instead, it is more related to solving your data-related problems. Rol's question is: so is data stored centrally at one place, or is data distributed across several computers? Again, thank you, Rol. Very brilliant question. So I hope that got answered. Gizi's question is, a job seeker, which job title will be easier for getting into big data after this course? After this course, can we get a project support or doubts through email? Okay, answering to your question, the this course prepares you for a Hadoop developer or Hadoop architect kind of role. Okay, and and regarding the project support or doubts, we definitely help you. I mean, on various doubts related to the course, even after the course is completed. A question from Balvinder. So you mean it's not the size of a single file, but amount of all the data used by logic? Yes, that's right. Shubham's question is, can structured data, which is relational in nature, be distributed into multiple machines? So Shubham's question is, can relational data be distributed in multiple machine? So there are two parts, okay? One is structured and other is relational. Okay, so his question is, can structured data, which is relational in nature, be distributed in multiple machine? Brilliant question, first of all. So what does it mean by structured? As we told you that a structured data has many columns, and structured data has clear definition of columns, and every column's data type we know upfront, right? The other part called relational means we also know the relationship between one row to another row, one table to another table. That's relational. Now, to distribute and divide relational data is really, really tough. Therefore, when you try to distribute relational data in the cluster, it becomes huge problem, because imagine there are two tables, and one table's few row go in one machine, and another table's few rows go in another machine. Now, to track the relationship between these rows is itself a very big challenge. And therefore, as we will study when we go into the details of NoSQL, we will study that actually having the relational system hampers the whole distributed nature. And that's why none of the NoSQLs, be it Cassandra, or be it, say, MongoDB, or be it any kind of NoSQL database. NoSQL database are these new generation databases which have been designed as distributed databases, as in a single database runs using multiple computers. Almost all of these NoSQLs are actually distributed databases, meaning when you store a table, this table is distributed in the cluster. Some rows on one machine, some rows on another. All right, good, great set of questions today. And all right, next question is from Ajay. Can you also provide an example of some unstructured data being handled in real life scenario? Okay, that's a good question. So his question is, can you provide an example of unstructured data? All right, let me try to explain this. As I told you that I was generating recommendations at InMobi, right? So what is it that I was churning? When I say 200 terabyte, what is it I was churning? These were the logs of Apache web server. What is a web server? It is somebody who responds to your website request. When you say facebook.com, it goes to the web server responds with the answer to you. And in the meantime, when it's responding and querying various systems and preparing the answer to your question, it creates kind of log. We call it log. Log means it's a uh, mm, it's the kind of, how should I describe log? Log is something which it keeps on noting down that did this, finish that. It's like a work log, the way we maintain the log on our files, that I finished this, finished that, supplied this, and built this. So similarly, the web server, which is giving you the website, is also keeping a track or keeping a record of what it is responding to you, and that's called web server log. Now, this web server log becomes really really huge, and it generally is an is in a plain text format. Okay, and to churn this data, you have to first figure out how the data is separated, and then you have to figure out how to reformat this data into a tabular structure to process these logs. So that kind of logs is an example of distributed sorry that kind of logs is an example of unstructured data. Kavita's question is, so data is broken into smaller, manageable chunk, routed to different computers, yes, and the analysis back to probably one place. So analysis is also done individually, and wherever it's required to do the analysis using all the analysis is done by each computer, that's that's also possible. Okay, so that what do you say? Whole dynamics of doing the analysis. Sometimes it's on one computer, sometimes on many, and so on. And that's where we will discuss during these 12 sessions that how can we divide the work. At most of the time, you will find that we will be tempted to do the computation on a single machine because you will find it difficult to divide it. And that's where lies the whole heart of this new generation of computing, how to divide and distribute your work amongst many computers. All right. Pankaj's question is, what is Hadoop technology for Raspberry Pi? So for Raspberry Pi, you can have clients, those clients which connect to either HDFS, or those clients will pump in the data to either HDFS, HBase, or any other system. All right. Now, Akash's question is, do we require ETL tool knowledge before taking this question? No, you don't. We will discuss two ETL tool. We will discuss two tools which can do the translation from inside out to Hadoop and from Hadoop. That's Flume and Scoop. A question from Anil. What's the difference between Hadoop developer and data scientist? Data scientist is somebody who has a good control or good understanding of statistics, and somebody who has a good understanding of various algorithms as well. Hadoop developer is somebody who knows programming, who knows inside out of Hadoop, and who can convert any logic provided by data scientists into Hadoop program. That was a question from Anil. I hope I've been able to answer. Kanan's question is, do we apply normalization techniques to Hadoop data? So that's a very interesting question, Kanan. So I will take a little digression here. Question is, when we are storing data in Hadoop, okay, so let me clarify here. When we talk about storing structured data in Hadoop in the form of certain tabular format, we talk about HBase. HBase is the database on top of Hadoop. And then, so question is, do we use normalization technique on HBase? No, we don't. We generally denormalize the data. Instead of keeping data in multiple tables, we try to put it in a single table. You will understand it more when we take few data models in case of HBase. All right. Next question is from Naveen. Log is nothing but writing to file. Yes, that's right. Thank you. Thank you, Akshata, for helping me out. That's good. A question from Raul. There was a mention that it is difficult to distribute relational data, which gave rise to NoSQL database. So then, how do we handle relational structured data? So that's a very good question, Raul. The quick answer to that is we try to denormalize, and instead of having our data across multiple table, we try to convert that into one table. As you will understand as we go forth, and you will, there are many techniques to get that done. All right. Now, Prithvir's question is, why do we need Hadoop when NoSQL databases do the same work? All right. So you will understand that as we go forward, Prithvir, but it's a good question. All right. Very great set of questions even before we get into big data. All right. Now these are the various characteristics of data that makes it big data. Okay, and those three characteristics are something you must have seen everywhere in every blog. Prashant's question is lot of technical terms for non-database person like me. Yes, that's true. Generally, in my normal usual talks, we don't get into these too many details. But today, interestingly, looks like we have very interesting candidate in the class. So I'm jumping a little ahead. So don't worry, things will be, you'll be able to. Uh, I'll keep the normal pace on the usual level. Okay. All right. So when we say big data and when we say that data data that's impossible to be handled by usual tools, what does it mean? What makes our data impossible to be handled by usual tool? What makes it? First is its volume. Imagine all the data gathered by Google Drive, all the data gathered by, say, Facebook, that data at rest. While because because to store that data itself, you require humongous storage. And to manage that storage, like which data is where, in case something goes wrong, where is our backup? How do we distribute that huge data such that all the devices are utilized uniformly? That kind of problem pushes our data into 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 the big data domain. And that's where, when your data starts growing big, and when the challenge is where to store it, where to keep it, and where to how to keep its backup is something makes your data big data. Okay, so let me rephrase. The volume of data can push you into making your storage distributed. Making the storage of data distributed is the first step towards big data. Second is the velocity. Now, what do we mean by velocity? Imagine that you launched a nice website and there are millions of views coming to your website per second. How do you handle that? One computer cannot handle that kind of velocity, and therefore, to handle that kind of load, you need a distributed computing. The other example of velocity could be, as I'm giving the talk right now, the data being generated from my side is being distributed to around 100, or say 100 audience. I'm not sure how many audiences are there. Say 100 audience. So this is speed of data which is going from my side and being distributed to all is something. And there could be hundreds of people like me who are conducting webinar at this instant. So this velocity is something that pushes you into use distributed computing in on the server side to huge handle huge number of requests parallelly. All right. So imagine that at every instant, so many devices are checking the Facebook feed, Facebook messages all the time. And how is Facebook managing so many requests per second? The answer is big data, or the answer is distributed computing. So when I say big data, the connotation you should carry is distributed computing. All right. Next is variety. Now, this is something very interesting. Sometimes what happens is even though even though there is no volume and there is no velocity, but the complexity of your problem is so high that even the small data pushes you into into a situation where you need a distributed computing. Imagine this. Let's say you want to travel from one point to another, and you are looking for path, looking for a way to go from one point to another. Now the data could be hardly few GBs. The map, the size of the map could be hardly few gigabytes. That's not volume. And the velocity is just one request. But since you want the response in say reasonable amount of time, say 20 seconds, question is, can a computer find the best possible route in this 1 gigabyte map or in this country's map in 20 seconds? All right. And generally the answer is no, because it has to go through all the permutations of the ways and tries to find the best way, requires a lot of computation. And that's why when we say variety, you should always imagine the complexity of problem. So this complexity of problem can push you into using distributed computing. That's why today, if you talk about if you talk to many researchers across the globe, most of them are using distributed computing or parallel computing in order to solve problems like biological problems, like DNA related problems, where data could be reasonably big, but not really big, like not of Facebook size. But their main problem would be how to solve the data in a solve the problem, solve the complexity of problem in a reasonable time. Okay. So therefore whenever so therefore these three things, the volume, how big is the data, velocity, how fast is the data coming, third, how complex is the computation, these three things push your computing into big data computing, or pushes or forces you to convert your thought process into a distributed computing being. All right. So these are the three things. I'm skipping veracity and value because I feel that those are mostly the what do you say marketing terms. These are the three basic properties of a problem that might need to be solved by a big data developer. So, because as I see that the marketing machines across the globe are at work, and they keep adding V's to this definition, and I'm sure by the end of few years they will have the whole dictionary of the all the nouns from the dictionary which are starting with V into the definition of big data. They will have V for vendetta as well here. All right. So, a question from Akshata. Most of the examples of big data related to logs would we call billions of rows of health insurance claims with related demography? Can that be considered big data as well? Yes. Billions of rows billions of rows from a database health insurance claim is actually a big data. Try to do a computation on on say their try to find similarities between those records, or try to cluster these billions of records into say 20 buckets. It would not be possible without using distributed computing. All right, so that's why billions of rows can be considered as big data. All right, so millions of rows are not big data, but billions of rows are. We'll see it very soon. Okay. A question from Akash is, what is the size of large data and speed of data processed quantitatively? From what size and speed do we call a data as big data? Very, very difficult question to answer, Akash, but it's a very valid question. Okay, so when somebody says what is the size, you should generally ask, what is it that you want to do with this data? And then if your computation says that, hey, this data, this kind of answer cannot be done, cannot be answered, this kind of question cannot be, this kind of computation cannot be done in a reasonable amount of time on a single computer, even if the computer is supercomputer. Okay, then if the answer is no, that no, we can't handle this kind of computation on a single cluster in a reasonable amount of time or in a given time, then the answer is, then you look forward that can we convert this problem into distributed computing, and then can that be answered by many computers in together? And that's how we look at. So let me take few examples on the same lines. All right, let me try to take the answers on the same lines. All right. Okay, so first question is, in case those people, some of you who are drowsy, okay, it's just a little uh, nudge. Okay, so can you tell how many bytes are in petabyte? You're free to use Google. And yeah, yes, good. Nandkumar says 1024. Okay, let me not announce it. Great, 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 Pratik. All right. Yes, anybody else? How many bytes are there in a petabyte? Okay, all right. A quick answer. Good. Some of you have answered correctly. So those who have answered 10 to the power 15 is also right. 2 to the power 50 is also right. And 1025 to the power 5 is also right. Good. Very good. All right. And I'm not sure how much is quadrillion bytes. Okay. All right. So yeah, I think that's correct answer. All right. So the quick answer is it's around 10 to the power 15 bytes. And the way you remember is kilo, mega, giga, terabita, and so on. And kilo is 1024 bytes, and mega is 10224 kilobytes, and so on. Okay. The important part to understand is, what is a byte? Byte is kind of uh, an array of 8 bits, and every bit can only have uh, you can think of a byte as 8 switches, 8 electrical switches, which can hold the state of on or off. Okay, it could be on or off. All right. And with 8 switches, the total permutations possible is 256. And therefore, it can store a petabyte data can store a lot and lot of information. Great. All right. Now, here is the question to all of you. Let us say the assignment is very, very simple. Assignment is count the number of vowels in a petabyte data every day. Count the number of vowels in 1 petabyte data every day. Okay, if you have to do that every day, can you do it by yourself? Can you do it by a big computer, or would you require a distributed computing? Anybody? So do you need a distributed system, or can you get it done on a single computer? Yes. So there are two important aspects here. The work that needs to be done is counting the vowels in 1 petabyte data, meaning we should be able to read 1 petabyte data. And in how much time? In 24 hours. So question is, can that be done on a single computer? Can you just read 1 petabyte data in 24 hours? Because counting the vowels is a very simple assignment. You can just keep on reading from one end to another, and in case it's A, E, I, O, U, it's a vowel, otherwise move on. Okay, everybody else is saying yes. Akshada is saying if the data is partitioned, we can do it on one system. Balvinder is saying, I think we can do it with efficient code. We will answer your question. Okay, this is very, very important. Now, Balvinder is saying we do process 10 gigabyte file using Vim editor within 2 hours. The question from Pratik is, how is data stored? Data is stored on normal hard disk. So question is, Balvinder, as you're saying that you can process 10 gigabyte data in 2 hours. Question to you is, how much time will it take for 1 petabyte? Because 1 petabyte is 1 million times a gigabyte. Or you can say 100,000 times 10 gigabyte. Therefore, therefore, it could take around 200,000 hours to just go through that data. A question from Pawan is, reading from the disk may take more time. Brilliant, Pawan. Thank you. And yes. So the answer is yes, we would need the distributed computing architecture for doing this kind of rudimentary work. Here, the problem is not velocity, the problem is not complexity, the problem is only plain volume. Okay? All right. Now, this will answer your question. So, how much time does it take to read 1 terabyte from hard disk? Anybody? If you have one hard disk, of 1 terabyte full with movies, and you want to give it to another friend who has come to your home with his own hard disk, how much time would it take to copy 1 terabyte data? Or, I mean, copying actually involves writing, so that's not a right analogy. So, time to just read 1 TB data from hard disk. I'm not talking about solid state hard drive. Subham says 5 hours, Pratik says 3 hours. Anybody else? Any guesses? Vikram says 10 hours. Anu says that if he's a good friend, he may not return. Okay, all right. Akash says 5 to 6 hours or more than that. Surendra's question is Surendranath question is depends on USB port and RAM. But my question is, let's say, okay, that's a very good question. Let's say the best possible USB is 3.0. Let's say you have USB 3.0. And do you think it would depend on the RAM? Akash's question is if it takes 20 milliseconds to read 1 megabyte from disk, okay, good, good. You're going in a very correct direction. It would take around 6 hours of time, and remember, it wouldn't depend on RAM because RAM is just to keep the data in transit for the computation. Bigger RAM would not make reading the data from hard drive faster. Because let's say we are just scanning the data from left to right and from top to bottom, we are not doing anything else. In that case, you don't require a great processor, you don't require a great RAM. A normal, very low end computer can do the job at the same pace. Okay, here the problem being the hard drive. Hard drive is slow. It takes around 6 hours to read 1 terabyte data from hard drives. Okay, this is a general graph showing the digital data has grown really, really fast on an exponential term, and 2002 was the time where it was noticed the beginning of the explosion of the data. Now, when we talk about this kind of computing, okay, this is a very good point from Tracy. Tracy's point is, I was writing 12 terabyte per day. Wow. And writing is slower than reading. Yes, writing is approximately 5 times slower than reading. Ooh, okay. So probably you were using really, really high-end infrastructure. And what systems were you using, Tracy? All right. Good. So yeah, Tracy is saying that can't divulge. It's a little confidential. All right, we respect that. So yes, so must be you must be using really high-end systems in order to writing data, and writing 12 terabyte a day is actually remarkable. So so as you can see that in a day, if we are talking about reading 1 terabyte in 6 hours, so you can hardly read 4 TB in 24 hours. But if you go into little high-end systems, you could actually do it maybe 4 times than that. Okay, all right. Next is Why do we want to talk about big data now? Why are we hearing big data now? All right. Why? What has made it? What has made this humongous amount of data accumulate in various organizations now? All right. Why did this happen? So there are three things to it. One, connectivity, hardware, and software. These are the three pillars of the whole computing or most of the engineering you hear that today. On one end, the smartphones or the devices became cheaper, faster, and available, cheaper, faster, and smaller. The phones or the devices kept on becoming smaller, cheaper, and faster. These are the three criterias which most of the hardware companies operate. On other hand, the on other hand, the connectivity between various devices became very much possible, very much easier. As of today, there are around 12 things or 15 things connected to our router as of now, and even our baby monitor switches and everything getting connected over the Wi-Fi, Bluetooth, and NFC, and of course 3G, 4G, and 2G. So the other evolution that has happened is in the connectivity as of today. Now, when the hardware was possible and the connectivity was also available, then the evolution of various softwares happened, and that's why we have so much of data today. So the way you can look at it is software and hardware combined produce a lot of data, and the connecting technologies or the connectivity distributes data and multiplies data. So effectively, when because of these three criterias, the data has been growing at a fast speed uh, in almost every organization. All right. Now, next question to all of you is which components out of these impact the speed of computing? Out of these components, which ones impact the speed of computing? Yes? All right. That's right. All of above. Okay. So when we think about computing, it's not only CPU and memory. The rate at which you can read data from the memory and read data from the disk matters. So when we think about computing, we think about these four pieces of hardware. Okay. Of course, every piece of hardware in your computer is important, but these are the four generally known piece of hardware. One is CPU. So CPU is somebody which reads data from various hardwares and then decides on what next to do. So CPU is somebody who is always busy. But interesting part is, as opposed to the general understanding, CPU is never a bottleneck. Okay, if you look at our CloudX Lab, for example, if you log in into there, those who have taken the account, you would be able to log in. If you log in, you will see that none of the computers ever reaches even 90% of CPU. Okay, so although CPU is the most important thing in the computer, but it is hardly a bottleneck in our usual operations. Okay. Second is RAM. RAM is something which is very, very important because most of the while computation, we put the data the CPU puts the data into RAM and reads from there. So RAM is quite fast, and that's why we keep data temporarily into RAM, and we can access anything very, very quickly from the RAM, unlike the disk where we read sequentially the data. Next is the disk size and speed. This is something very important when we deal with the data. So disk size and speed, as in how big the disk you have and what speed does it have. The fourth is network. Network is something which we never thought as part of the computation stack, but because of recent movements, network has become very, very important. So the way it happens is when the data is huge and you can't fit into the RAM, or you can't fit into the registers, you put it in RAM. You as a your computer program, you put it in the RAM. If the data is not fitting in the RAM, you generally keep it in the disk. And when disk overflows, you put the data in the network. And at that point of time, network starts mattering. Okay? All right. Out of these four components, at least you will hit a bottleneck on one hardware that you can't remove. And that's where you'll say that I can't solve it using a single computer. I need a distributed computing environment. Let's say the problem which we discussed just now, there, the thing which will get bottlenecked would be the disk speed. Not the disk size, but disk speed. But sometimes your the data you might have to store is say 20 terabytes, and you don't have disk of that size. So either you will keep an increasing number of disk on the same computer, but that's not the motherboards do not support beyond say 6 7 hard disk, and that's at that point of time you might have to push the disk to the network. Okay, so basically you will always hit a bottleneck on these components, meaning you would not be able to solve the problem using one computer, and that's when you will use the distributed computing. All right, now let's talk a little bit less technical and more real life. Who are the example big data customers? The first one is the recommendation engines. These were the beginners. These were the beginners in the big data industry. These were the beginners who proved the value of the data. The recommendations which you see at Amazon saying you may also like this, 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 and this. Okay, that's recommendation engine. All right. So let me just skip ahead to recommendation engine. All right. Let me. Uh, okay. So all right. So you can see that there are two kinds of recommendations here. One is handcrafted, while other is auto-generated. The one on the right-hand side is handcrafted and human-assisted, while on the left-hand side, customers who bought this item also bought that. Now, if you look at this query, if you think in terms of how, if you are in that shoes, how will you do this? How will you say, how will you generate this list of things? Customers who bought this item also bought this. If you think about this query itself, it's not complex. You can write maybe in like three select and group by statement from MySQL. But since the data is huge, solving the data, solving this kind of problem takes a little bit more than a simple SQL query, right? And next is that you might say that, hey, we don't need that much data. Why don't we just sample the data and create recommendations, right? The answer is more the data, better the recommendation. Because sample is a small set and you may not get the real insight. Therefore, almost everybody realized that the company with biggest number of sales records data, biggest history transaction have better recommendations, right? Because the biases which happen, the outliers get removed if you have really big data. Therefore, to exploit the big data, to exploit data, the recommendations were probably the first one such application which converted data into money. Specifically, companies like Amazon, they keep on sending these recommendations in the emails, showing it on the website and everywhere. And it has been proved that more than 20% of their revenue happens because of these recommendations. And it has been proved by by many other companies. It has been proven by many other companies who do the same thing. So there could be another kind of recommendation where we know the information about the user as well. We know who this user is similar to. All right. And if you have to do the same thing tomorrow in your organization, it could be quite straight if you have a Hadoop kind of stack. You just prepare one table with three columns in which you have user ID, movie ID, or ratings. In your organization, you might be doing something else. Um, so the second column would be different, and so on. And so all you have to do is, if you have a Hadoop environment and you have the data about the history of about various users and their transactions, you can churn that data and prepare this three column data: user ID, product ID, and the rating. Rating has to be between 1 to 5. Now, if you feed this to Mahat is a command line. Mahat is a command line. If you run the Mahat command line on in a Hadoop cluster, you will be able to generate the great recommendation saying this user would like this kind of product with this much of chances, right? So in today's time, the thing which required data scientists at Amazon is very much possible by a simple developer, because the tools like Mahal are available for you. Okay, so this is how you can generate a quick recommendation. There are many other tools. I'm just taking one simple case. All right. So all of these, so the important part here is that generating this great recommendation requires few things. One, you should have access to the data. Second, you should have the Hadoop cluster. Third, you should know how to use Mahat command. That's it. All right. So you can generate this recommendation, and once you have generated this recommendation, you can push these recommendations to your MySQL and let the web developers present it to the end user. Okay, so we'll go into the exact detail and we'll show you how to do this with the real life data. A question from Akash. Can you please tell me more about iBeacon technologies that is now being used for recommendation? I would need to go through iBeacon technologies. Okay, Akash. Maybe it's IB beacons are small Bluetooth sensors which you attach across the buildings, and then you can send information to the various apps installed by people. Now, a question from Pratik is, look for other purchases with the same product and show them. Yes. All right. Good. Now, this was a quick example of recommendation. Let's take a little break. Okay. Let's take a little break and little break of 10 minutes and back by 46 p.m. IST. 9:46 p.m. IST. All right. I'm going to pause. All right, so I'm back. Should we start now? Yes? Great, great. All right, so before the break, we were talking about the recommendation systems. The other important use case, which is quite popular, and let me make notes as well. There are a few things that require notes. All right. The okay, here we go. So question is like Hadoop, what are the other big data systems? We'll discuss this very soon. Okay. Now coming back to it. All right. The other commonly known use case of big data systems is the sentiment analysis. Sentiment analysis. Okay. So what do we mean by sentiment analysis? We we basically try to understand how the the audience is responding to your product or your brand or an event. How is the response, whether it's negative or positive or neutral? Okay, this is called as sentiment analysis, and typically what you do is on the x-axis you draw the time, while on the y-axis you draw two things: one, negative tweets or negative sentiment, or and the other graph you plot is the positive one. Okay. Also, on the timeline, you mark the various dates on which some action happened, such as your market campaign got launched, you got a press coverage, or you launched a new product. Okay. So, so sentiment analysis essentially tells you how is it going, how is your how are the people responding to your brand or product. Okay, whether they're happy or they are angry. Now, how do you do this generally? So we'll cover this as a project in case of our Hadoop session. The way you do it generally is you download the data from Twitter. You download the data from Twitter, and after downloading the data from Twitter, you try to convert each tweet into a number. And that number is the sentiment. And this number can be done in a many more ways than you can think. One, one could be that you break down every tweet into into words, and for every word you find out from a dictionary. There are dictionaries which can tell you whether a word is negative or positive. Okay, and then you can sum all the sentiments of each word and create a single sentiment, and so on. So this way you can clearly clearly tell the sentiment of the public against your product. The problem with this approach is that you cannot predict whether it's a humor or whether somebody has really liked your product. Also, the complications of a language can also be a deterrent to sentiment analysis. But lucky for us that if you have huge data,
The outlier messages, which are humor or which are confusing, are rare, and they get outrun by the usual straightforward messages. And that's why bigger the data, better are the results. Kavita's question is, what if both type of words are there in the tweet? So there are many ways to summing up. One way of summing up is you multiply minus and plus. Okay? You multiply minus or plus. Other way of doing it is by just summing it up, or you can basically put an XOR operation. So if you multiply the sentiments instead of summing up the sentiments of each word, if you multiply, then what happens is that if there are two negatives, they become positive. So when I say it's not bad, it means it's good. Okay. So there are many ways to reach to the number, meaning to convert the sentiment of a word into sentiment of a sentence. Does it make sense to you, Kavita? All right. Okay. These are the common myths about big data, and it always means above or in range of terabytes. Sometimes, even if you have terabyte data, you don't need distributed computing because you just need to keep this data stacked. You are not doing any processing. Big data is always about social media and doesn't apply to you. That's also wrong. And there are many more cases where big data is being used even in the normal operation, because in those operations the data has crossed a general limit of computing. It will replace EDW in a way, yes, but not completely. Okay, so most of these big data systems would be part of EDWs. EDW is Enterprise Data Warehousing. It's just a buzzword, not a practical application. This is, of course, a myth because I have seen many practical applications myself, and not since now. I have seen the practical applications of humongous data since 2002. Okay, so if you can build a system which can accumulate a lot of data related to your business, you will be the winner. All right. It's a new concept. No, it's not a new concept. It has been there for quite long. Will be the future? No, it's the present. Is expensive? No, it's not expensive. If you think about the money an organization pays to oracles and other databases, the cost of establishing a Hadoop cluster is a fraction of that, because almost almost every software in the Hadoop structure is open source and public and free. It's only the cost of implementers that you need to pay. But that's also going good because there are many more people who are coming into the domain now. It's only for data scientists, or it's a magic? No. Before the algorithms like Mahat is a library of algorithms. Mahat came into play. The game was about data scientists. But today, given all the tools and library of algorithms, everything is available to a developer at the fingertips or an analyst. It's available everywhere. We will build it when we need it. My quick answer to this kind of argument is, when you need it, you won't have it. Next is, the big data is about Hadoop. No, it's not about Hadoop. There are many more systems which are there, but Hadoop is probably the most complete one as of today. The salary trends, you can clearly see that Hadoop is the winner. Similarly, my sources may be a little older, but I last checked Indeed and I found that the trends are actually better than what they were a year ago. All right, you can check at indeed.com again. Now, what are the other alternatives to big data solutions? Okay, all right. There are many other solutions. One is Hadoop, along with the Spark. This is probably the most complete ecosystem of components because while on one hand, Hadoop provides you great way of storing data and provides you a huge library of algorithms and tools to do computations using small memory. And Spark provides you a faster computation by utilizing more memory. The other systems are these NoSQL databases such as MongoDB and Cassandra. These are NoSQL databases. These are new generational databases. But the problem with these databases is that they can store data and they can do a rudimentary computation. The library of algorithm and the power that is provided by Hadoop is far beyond what can be provided by Cassandra and MongoDB. Okay, and when you have Hadoop, you have systems like HBase which compete with Cassandra and MongoDB. Then the fourth system you have is Google Compute Engine. The fourth system you have is a Google Compute Engine. If you or AWS, okay, AWS S3, those are the places. Those are good if you're okay with handing over your computation to Amazon, okay, and you are okay with letting your data out of your your own data center. Okay, so if you are okay with uh, handing over your data to Google or Amazon, then Google Compute Engine or AWS would be good for you. A question from Pankaj: does data visualization library available on Hadoop and Spark, and which library? Okay, let me answer these questions. There are three questions that need answer. I hope this got answered, Rol. And then these two more questions need to be answered. All right. All right. Let me try to answer these questions. Now that I have shown it on the screen, I don't have to repeat these questions. Like Hadoop, what are the big data systems? This has been answered. Could we have the use case where devices could be part of the system extensively? Could we have a use case where devices could be part of the system extensively? So, okay, let me go back to the use cases then. All right. Does data visualization library available for Hadoop and Spark? This is something I'll answer now. All right. So the interesting part about all of this is the visualization libraries remain the same before big data. Whatever you used earlier, you can use the same. So your visualization tool, say whether Tableau or BERT, or say there are more BI tools, any other BI, they can connect to systems like Hive or systems like Space and present the data. Okay, all right. The other part to understand for all of you is that When we want to visualize, you generally convert big data into either insights or visually meaningful data, and then you plot it. Okay, so you basically convert big data into something meaningful or visualizable data, because big data, when we talk about millions of rows or billions of rows, it doesn't make any sense to plot it. Okay, you generally have to summarize it, you generally have to generate statistics out of it, and then hand it over to your usual visualization tools which can visually represent it. Okay, so visualization tools are not part of the stack. A question from, okay, so this one I'm yet to think over. There are many use cases where devices could be part of system, such as, let's say there is a device which is measuring the temperature across the globe. There are millions of such devices which you have put, not say hundreds of thousands of such devices which you have put at various places in a country. And those devices are continuously pumping data to Hadoop, and then there it's getting processed, and the statistics or the visualization is being done using your BI tools. All right, BI tools will do the visualization, you will do the, okay. Next question is, does this mean that Google Compute and AWS are cloud based while others are on premise? Yes. Next question is, Apache, Hadoop, and Spark are different entities or both work in collaboration. So Spark can run on Yarn. Yarn is a part of Hadoop. Okay. So on top of Spark can run on Yarn, and Yarn is a part of Hadoop. So essentially, Spark is also counted as part of Hadoop. Okay. Yes, thank you very much, Akshata. I actually missed going back to the slide. Okay, so we can choose, can we choose Azure AWS cloud technology to handle big data processing for us and give back the result? Yes. Many organizations choose that way. All right. All right. So we missed this slide. I'm coming back to this one. So we talked about recommendation engine, search query, sentiment analysis, and search quality. So this search quality is something related to Google as well. So to improve their search quality, they keep on taking the feedback loop from the user back into counting how important is the page. If Google knows that you're spending a lot of time on the page, it knows how good is a page or how bad is a page. Okay, so other than that, even if you are building your own search engine in your organization, there are many more insights that you can put in using the big data technology. I'll give you an example. So when we were building at T-Bits, we were trying to build a system whereby when people search for something, we should give very good results. Okay. So what we did was, apart from using something called Lucene, which was the parent of Solar, SOLR. So apart from using that, we were we were also doing a couple of more things. So imagine that when people search for Bluetooth, they can search for blue space tooth, they can also search for Bluetooth, and they can also search for blue dash tooth. Now, you have to autocorrect the user, or you have to predict that user is actually looking for this. Now, to prepare this thesaurus, to prepare this kind of a dictionary from where you can pull the plurals, right? Not plurals, pull the similar meaning words, you would require big data systems to churn. Or let's say somebody is searching for something in your data, and what you want to do is you want to auto complete it. And for auto completion, if you are crawling, if you crawl say Wikipedia and try to prepare the next word suggestions while the user types in, then the overall search quality would go really well. Next is the A/B testing. This is something new for lots of people. So what does it mean by A/B testing? A/B testing means that you are comparing the results of two test cases. Are you able to hear me? Because looks like Satish is not able to hear me. All right, so at least Pawan can hear. That means my voice is clear. All right, I'm sorry. I think. Okay, let's go ahead and talk about other things. So, A/B testing is something very important. This is something which not many people use in computing. When you have huge statistically important users, then you can do many magical thing on your website. Let's say, let me talk about Amazon a bit. So, buy now button, to change the color of buy now button, what they did was they did not reach to the orange color just like that. They did a lot of experimentation. What they did was they first changed the color of buy now button to blue, and then showed the color blue color to few fraction of small fraction of people, and then saw and then observed how many of those people clicked on buy now. Similarly, they ran the test cases against, they compared red against blue and orange and so on, and observed that orange was the one which was giving the best results. Therefore, this mechanism is called A/B testing. It comes from drug testing, whereby you give some people only the pacifier, some people the drug, and observe which patients are getting better. In the similar way, you give some people one different version of software and some people another version of module, and then you observe which ones are more happy. Facebook, Google, and all of even Amazon does it all the time. Right now, the total permutations of the website are more than 1,000 for Amazon, that I can say for sure. Because every feature, the website is made of these small features. Every feature is having at least three variations running at the same time. And these three variations are competing with each other. All right. So that's A/B testing. In telecommunication, the big data, using big data, you can stop customers from leaving you, and the network performance optimization. You can avoid customer leaving you if you try to understand their behavior over a period of time and try to understand how many calls they made to to various people, how many calls were dropped automatically, and so on. Next is the network performance optimization. If based on the data, if they can tell clearly that which network is more busier than the other at what period of time, then they can manage the hardware, the resources, and so on. Third is calling record data analysis. So many people can use big data systems for many different industries, and telecommunication is one of those, because in telecom industry almost every data is big data. Okay, they can do other things like analyzing network to predict failure. If they have the past history of the network failure and various other parameters, they can prevent that from happening. Next is the government. In government also, everything is very large scale. Whether it's fraud detection, cybersecurity, welfare, and justice, everywhere the computing would be of very large scale. Same is the case with healthcare and life sciences. In healthcare as well, everything is complex, fairly complex, and of a huge data size. Okay, whether it's even the information exchange, the whole thing requires fair amount of storage and computing. Gene sequencing is one big complex where the variety, V for variety, matters in case of gene sequencing. Third is the healthcare improvements. Fourth is drug safety. Okay, so these are the few use cases. There are many more use cases. Almost every industry is trying to figure out how they can improve improve their solutions or their products by using data. And when they do that, most of these companies realize that even to store that amount of information about their customers requires huge storage, huge computing, and huge, uh, and hence they generally require a big data solution. All right. So now coming to the important part. Let's start with the discussion of Hadoop, and then we will go through the stack and understand what what are the various components which are part of Hadoop ecosystem. I'm hoping that I have not skipped any answer. All right, good. So we'll just go with the basic of Hadoop. So, all right, I'll take a step back and try to explain. So, a person called dog cutting. Dog cutting was trying to implement a, a crawler so that he could build the search engine. So he was trying to build his own kind of a search engine, uh, and it was a hobby project. And when he was doing the search engine, he realized that it's not easy to store huge data. So he was actually stuck that current solutions do not scale to the web. Current solutions, whether it's whether it's current solutions, whether it's database like Oracle or it's a file system, they were not able to solve his problem. And he was trying to tinker around his own systems. And lucky for him, at the same time, the Google released three papers. One detailing how is the file system, Google file system made. Second, how is the Google map reduced for the computation made. And third, how is the Google's big table made. And based on three, dog cutting and Mike Caffrell joined dog, and then they started with this. So they took those three papers and implemented all three of them. Google File System became HDFS, Hadoop Distributed File System. Google MapReduce became Hadoop MapReduce, and Google Big Table became HBase. So these three papers by Jafreen and Sanjay Gemawat and one more researcher, they were the they were the kind of they were the basic what do you call this, the fundamental ideas were provided by these paper, and then that's how Hadoop was created by Docketing and Mike Caprella. They were trying to build their search engine, but they were getting stuck. So, lucky for them, Google came along and provided these papers publicly. And before that, Amazon has provided NoSQL, and the design of NoSQL, and that led to new kind of databases. Now, it's named after a toy elephant. It's open source, Apache. It's quite popular and powerful and well supported. It's a framework for handling big data. Okay. And when we say big data, all of these tools which are under the umbrella of Hadoop. So Hadoop started with these three tools, but slowly, the peripheral tools started joining the group and they became the part of the same parent Hadoop project. As of now, there are around 14 projects which are under the umbrella of Hadoop. Okay, all of these tools have one common behavior, have these common features. That is, they're all reliable as in if there is a failure in one of the machine hardware or network, they still work. Second, they're scalable. Today you have 20 machines, it's working fine. Tomorrow, if you want 5 more machines, you can add and they will still work. All of these tools are reliable and scalable and distributed compute for distributed computing, for dividing work amongst themselves and getting it done. Most of these tools which are under Hadoop are written in Java so that they can run on every hardware and software. There are a few questions, let me answer those questions. Pankaj's question is Hadoop systems are written in which language? I think that got answered. Next question from Pankaj is that the Hadoop system could be deployed on cloud. Yes, that can be done. A question from Akshata that could you explain BNC one more time? So, dog cutting was trying to implement a search engine which was supposed to be competing with Google, and then he was not able to make the progress. At the same time, Google published these three very groundbreaking papers how they designed Google file system, Google MapReduce, and Google Bigtable. And actually, the whole idea of Hadoop is based on these three papers from Google. Pankaj's question is Hadoop system could be deployed on company intranet computers. Yes, it can be. But generally, you keep these systems separate so that your cluster keeps running and does not shut down. All right. Balwinder's question is how does Hadoop solve the problem? Because even Hadoop has same network, CPU, hard drive, and RAM. Okay, very good question. Let me copy paste it so that everybody can see the question. Okay, now this is a very good question. So the way Hadoop solves the problem is by the way of software. We know that hard disk fail. So instead of keeping data on one computer, Hadoop automatically keeps the data on many computers. Second, CPU and RAM. Instead of executing your program on one computer, it will execute the program on many computers. Network speed. Instead of transferring data over the network, it would transfer the computation and take it to the computer which has a copy of the data. So, as we go down into the details of the components, that's why this whole stack of uh, components are there in this class, so that these questions can be answered. How Hadoop or any of these components solve these problems given the fundamental same hardware. Josephine's question is big data not for small companies? No, big data could be used by really, really small companies. Imagine when Google was started, it was two-man company. And that two-man company actually crawled the whole internet and churned the data and built brilliant tools to rank the pages across the globe. Okay, so it can be for the small companies provided people have a vision of figuring out how to use the data for their use case for their customers, and how can they exploit various data available globally. Do I make sense, Josephine? All right, now let me take you through the stack of Hadoop. All right, at the bottom of this chart, you see HDFS. There are two tools which are not available in this that we will go through. One of them is Zookeeper and other is Spark. Okay, so let me describe this diagram to all of you. At the base of the ecosystem is HDFS. It's a new kind of file system, the way you have C colon, D colon, and so on. It's a new kind of network file system whereby data get distributed on many computers. And data is so strategically replicated that you do not miss the data at all. You do not lose the data at all, and instead the overall performance of the file system is compared to a single machine. I mean, I mean, each individual reads is equal, actually faster than the single machine. All right. Now, that's Hadoop distributed file system. Hadoop distributed file system is the most important component of Hadoop. Okay. On top of HDFS stands everything else in the ecosystem. All right. Now, to push the data from your traditional systems into HDFS, you either use Scoop or Flume. Okay. So Flume keeps on continuously pumping data from various machines onto HDFS, while Scoop can copy the data from your structured data sources onto Hadoop ecosystem. We'll go into this again. Next is, now we have a layer which can store any file. The way you have C colon, D colon, or your normal file system where you store data, that need is being fulfilled by this great Hadoop distributed file system. Hadoop distributed file system can store 50 gigabyte file or a terabyte big file, and it can store it can store a huge data. Why? Because Hadoop distributed file system is made up of many computers. Many computers are connected together, and some data is in one computer, some is another, some in another, and some in another. And there is a central system which keeps track of which data is where. So That's what is Hadoop distributed file system. Today, you have, say, 10 terabyte data, 10 terabyte storage, and tomorrow you need 20 terabyte of storage. You can add more computers to the same pool of machines and you will have more storage available for you. That's HDFS. Now, once you have a good file system to store data, the next thing you need is a way to process the data. Way to process the data. This data is stored on HDFS. How can you process it? And that's where a system like Yarn comes into play. So Yarn is also distributed. So you install uh, parts of Yarns on many machines in the cluster, whereby you will give orders to Yarn, and Yarn will execute those programs or will keep your program continuously running on these many machines in parallel. So Yarn is like an operating system, while HDFS is like a file system. So Yarn can execute anything in the network. Next is on top of Yarn. Now Yarn is a plain vanilla kind of an operating system on which you run things. You request Yarn to execute programs. But how do you build programs in which your computation can be divided? Okay, because you cannot, if you are churning huge data, you cannot write a straightaway for loop. You cannot say for my first line to the end of the line execute this program. Why? Because in that case you will have to pull the data and then do the and then execute, right? But in case of distributed computing, you generally write code like an SQL query saying filter my data based on this criteria or group my data based on this criteria, and that query can be executed in a distributed fashion on the cluster. That query, so some part is on one machine, that some part of data is on one machine, some part is data on another, and if you are running, say, a filter query like select star from blah and blah, right? That where so you, let's say you are running a query select star from my table where customer ID equals 10, right? So this query can be run parallelly on many computers and the result can be aggregated together and displayed to you. For this, for running this query, you don't have to bring all of the data on one computer and then run it. And this kind of computation, where a query or a program can be distributed across a cluster, is something done by MapReduce. In case of MapReduce, you write two functions. One is map, other is reduce, and that MapReduce maps gets executed near the data, and results of maps are aggregated together based on the key generated by map function, and then reduce function combines all the values. Okay, so MapReduce is more like a group by clause in SQL where first you group the data based on certain criteria and then aggregate the values. Similarly, maps and reduces, maps convert, map tries to group the data while reduce combines all the values for each group. Now, so MapReduce is a paradigm of computation. MapReduce is a layer on top of Yarn which executes your construct, your maps and reduces on top of Yarn and on top of the data. So MapReduce, we'll go into more details. We'll take around 3 sessions to understand in detail why do we need MapReduce, why do we need all of this computation. Okay, now the new generation MapReduce called Spark. Spark is a competitor of MapReduce. Spark tries to utilize more memory. It's a little more aggressive design than MapReduce. Tries to be little more considerate of the memory of a computer, and while Spark is a little more aggressive in terms of utilizing memory, but Spark gives you wonderful results and is really really fast. Okay, so Spark also runs on top of Yarn, and then you have HBase. And what exactly does HBase do? HBase stores while HDFS was storing files. Okay, you just take a file and copy it to HDFS, and there you have files. Now, HBase is a NoSQL database. It's more or less like a tabular way of storing data. And HBase is good if you need to modify data quite a lot. HDFS is good if you only have to append data, but HBase is good if you keep on modifying your records. Okay, to store records you use HBase. To store big files you use HDFS. But the interesting part about HBase is that it stores data. It stores its data files. You remember those data files in case of MySQL or MS SQL? They get stored in the file system. In the same way, HBase's data files get stored in HDFS. Now, since not everybody is a programmer and can write code, right? Therefore, people made things like Pig and Hive. In Hive, you can write query and it magically converts it into MapReduce. Okay, so if you have to query your data stored in either HBase or HDFS, okay, so that's where Hive comes into play. Hive takes the query from you, understands the query, and converts it into MapReduce and executes it on top of Yarn and utilizes HDFS and everything. So that's Hive. Hive basically is an SQL interface for you. Okay, is everybody with me? All right. I'll answer your question, Pankaj, after this discussion. Okay, great. Now, this SQL interface, Hive, would convert every of your SQL queries, whatever you give it to Hive, it'll convert it into MapReduce and then get it executed. MapReduce will get it executed on Yarn and will churn data stored in HDFS. Similar to Hive, there is a piglet. People realized that SQL was not a language for distributed computing, so they designed piglet, which is very similar to Hive, just there is a minor variation of the construct. Okay, there's only a very small variation in the construct, but Pig is more or less designed for distributed computing. Pig's design was so well that even Spark has borrowed the same design while writing the strategy. Okay, the RDD design and everything. So the way it, so Pig is more or less like a SQL, but little more simpler than that. You will get to know this. Then comes Mahat. Mahat is a library of algorithms, and anything in Mahat gets executed in MapReduce, and after a while it will get executed in Spark because Mahat's next version will be executing the algorithms on Spark as well. Okay, so Mahat is a library of algorithm. Say you want to generate recommendations, you want to find out similar items, you want to cluster, group various items into various buckets, and so on. So Mahat can do that using MapReduce. Then, as I was telling you, Scoop can pull the data from MySQL into Hive or HDFS and so on. Also, I forgot to mention that Hive comes with a relational structure whereby you can define columns and so on. But Hive stores data in its base, and whenever you execute query on Hive, it's going to convert that into MapReduce. All right. Now, if you have a large project, let us say you have to do the recommendation part. First, you will have to bring the data from somewhere, right? There you will use Flume. And once you have brought data onto Hadoop, you will process it. For processing, you will either use Hive, Pig, or MapReduce, or a combination of all these three. And then once you have cleaned up the data, convert it into three column thing like user ID, product ID, and so on, and rating. Once you have those three columns, you could feed that to Mahat, and Mahat will give you the recommendation which you can take and put it in your web server and serve your users. And that copying the output of Mahat into MySQL would be done by Scoop. So you can see that all of these tools are being used in a single project. And how do you create such project? And you would want to run it. You would want to run it every now and then. Every night at 12 o'clock, you want to run this recommendation generation tool so that your recommendations get updated nightly in your web server, right? So when you have many things to get executed periodically, you use Oozie. Oozie is a workflow solution which will convert the logic into, it will basically tie all of these things together just the way Apache Ant, there's the project management tool, I mean the build tool, or Make, or say Gradle. There are many more Make tools which can, or Maven. Similar to those kind of tool, Oozie is used for on top of Hadoop. Okay, when you have to get many things done, execute, import, and then process the data, run the Mahat, generate, copy the generated results to web server, and so on. When you have to do these things with a certain dependencies amongst themselves, then you use Oozie. All right, am I okay? There are a few more questions. Let me answer. Pankesh's question is, can I install HDFS on device running Raspberry Pi? Not out of the box. You will have to install it by yourself, but theoretically it should be possible. Next question is, Flume and Scoop are Hadoop client. Flume and Scoop are Hadoop client ecosystem running on individual computers. That's right. Flume and Scoop are basically, so Scoop is kind of client for MapReduce and client for HDFS. And Flume is also a client. So generally Flume is run on systems external to Hadoop, and it pushes data to Hadoop distributed file system. While Scoop is run on the nodes which have Hadoop, and it basically pulls data from outside or pushes data out from the system. A question from Ajay. So all the HBase operations is coming from underlying HDFS. Yes. Rol's question is, one machine in the cluster shut down and another machine updates the same data. How is the consistency maintained when machine that was down comes up? So let's discuss this question. This is a very brilliant question. And I would like to discuss when we are discussing HDFS. I'll take this question there. All right. So HDFS is built with this kind of problem, this kind of conflict resolution. A question from Anil: which components in this ecosystem is mainly used in machine learning? So Mahat is used in machine learning, and MLlib, which has been created on top of Spark, is also used for machine learning. That's not discussed here. Okay, and a question from: sometimes after using Amazon recommendations come up on Google search. For what I've searched at Amazon, do they use reading? Yes, they use something called cookie sharing, and in Google's terms, they are called retargeting. Okay. A question from Brawl: are Hive, Pig, Moth components used for data processing and performing analytics? Yes. All right. Good. So what we discussed, let me go through. So HDFS is really strong file system, as in it can handle the failovers and it can divide and distribute the data on many machines. In simple words, it handles the volume. Second is the NoSQL storage, which is basically for storing records, the way databases record store and file system record files. In the same philosophy, HBase stores NoSQL data. Okay, so HBase is great for hundreds of millions of rows and billions of rows and millions of columns. Okay, we'll go into the detailed design of HBase in session number 6 and why do we need it. Then we have many components which are part of the compute engine: Yarn, MapReduce, and Spark. People who are developers will use Spark and MapReduce directly. People who are from analytics background, they will either use Hive, Pig, or Mahat. All right. Okay. Hive is an SQL interface. It comes with a server as well. Okay. So whatever tables you have created, whatever queries you run via this server, they are run on top of MapReduce. Then you have Pig. It's also very analytics engine like Hive and can run queries on top of MapReduce. Then you have machine learning library called Mahat. It's a library of algorithms. And then you have Flume, which imports unstructured data continuously. We will give you a demo of how Flume can pull the data continuously from many nodes. Then is Scoop. It copies batch-wise structured data from MySQL or any other SQL server into HBase, Hive, and HDFS. All right, so this is the overview. All right, so I'll try to show you because we have some time, like 10-15 minutes. All right, there were few questions which were asked in the beginning. Are those clear, or if those are not clear, could you please ask those? So a question from Nand Kumar: what are the components would be covered in our class? Starting with HDFS, Yarn, MapReduce, Spark, Spark Streaming, NoSQL, HBase, Zookeeper. Zookeeper is something which we have not discussed here. We can discuss it later. And Zookeeper and Scoop, Flume, Mahat, and Uzi. These are the components we are going to discuss and show you one example of everyone, and then get into the details. Yes, hands-on will be on all components. Akash's question is, can you please explain Uzi again? Okay, so I'll explain it. So as we told you, as we discussed earlier, that all these components which you see here are utilized in project. So if you have a big project, say recommendation engine, so first you will pull the data, then you will run the computation, then you will push it back and so on. There will be at least 15 steps. Question is, do you run those 15 steps manually or you use some kind of a workflow? So that's where Uzi comes into play. In Uzi, you could define that pig script would depend on data imports and so on. So you could define this dependency amongst the tasks, and Uzi will execute those all dependencies in the right fashion. Did I make sense to you, Akash? All right. A question from Raul. Raul says that explain how CloudX Lab is implemented. Is it like one slash multiple servers connected to many machines? If one server, then what happens if the server crashes? Okay, so I'm going to take you to the CloudX Lab now. All right, and then we'll discuss this. It's a very good question. All right, now, so what exactly is CloudX Lab? CloudX Lab is basically a cloud-based lab for real life experience on Hadoop cluster. So when I started No Big Data a little while back, no, I mean 2 years back, I struggled with my class. As in, 20 days passed and everybody is still fighting and struggling to install Hadoop. Some people had BIOS problems, some people had memory problems, some people have their office computers don't allow installation, and so on. Okay, and some people uh, because on top of it, the virtual machine which is provided by Hortonworks and Cloudera, it's actually slow. It makes the computer slow, and people have this inertia. In my class, I also had this fear that if I run virtual machine at the same time as I'm giving my webinar might crash. So I avoided it, and that led to the realization that it's okay to just buy a cluster at Amazon and install my own cluster. Okay, and give the access to all the students. So we did that, and we were kind of first mover in the game. Nobody has done that before. Afterwards, almost every instructor has tried to do the same thing and learn from it, and started the I mean, started asking us. Now, I mean, I'm very happy with the fact that now most of the instructors use the same cloud lab for their students as well. There are around more than 6,000 students. They use our infrastructure, not on the same single cluster, but different clusters. All right. Now let's see this. Now let's see this. Okay. All right. So as you log in into my courses and you go to this page called Course Page Big Data and Hadoop 4th June, you will see the login password, right? You can see the login password. Okay. And once you log in there, if you go to CloudX Lab, there also, if you go to My Lab, you will see far more details here. There are some hands-on examples, and there are some lab credentials. You see, login, password, same thing what you have here. Okay, same thing is also displayed here. There's few more details which you can get from here, like this. See this? Now let's try to log in. Let's try to log in here and see. So the way you log in is, there are three things which are provided. Sure, Siddharth, you will get the recording, no worries. Okay, so now what you can do is either go to Ambari. Ambari is an interface provided by a company called Hortonworks. They are the provider of Hadoop. Similarly, there is another company called Cloudera. They are also the supporter of Hadoop. Then there is third company called Cubole and Mapr. They're also implementers of Hadoop. So one of the tools called Ambari is open source and is provided by a company called Hortonworks. Okay. All right. Now there is Hue. Hue is provided by Cloudera, while Ambari is mainly used to provision the cluster. Okay, what does it mean by provision? Installing components, seeing the health of various components, and sometimes installing, uninstalling, and turning off certain components. So you can see right now that total hard disk is 70% used. The total data nodes that are alive as of now are 5 out of 6, which means one is dead. So you can see that even though one node is dead, still the cluster would run fine. Okay, and how does it run fine? Let's discuss in the first session tomorrow. Okay, tomorrow we'll be discussing this. Then you have name node, secondary name node, 6 data nodes, and so on. Okay, so you can see the whole health of the cluster. All right, so on two machines, this matrix collector is down. So we can restart that, but since I'm not logged in from admin account, I can't do much. Okay, so this is Ambari. It shows you the overall health of the cluster. All right, you have all the components. Anu's question is, what about the data stored on that node? Because the data is replicated on many machines parallelly, 3 by default. Therefore, the data on that data node, which is dead, is anyway available. Okay, and anyway, now the same data is being copied onto another machine automatically. Okay, so that's something being taken care of by HDFS. We will go into the detailed design. Okay, so Ambari, this web interface basically provides you a way to do the administrative task from the browser, while for the developer or analyst, the Hue is the interface. Using Hue, you can interact with HDFS, as in you can upload your file, you can you can basically upload data. This is my folder, and all the data related to our course is stored in slash data. All of this is HDFS. Okay. Now, the third important component, which is part of the CloudX Lab, is console. This is something which we worked on and built so that our student does not have to install any client. We got sick of hearing that Microsoft has removed Telnet and SSH PuTTY need to be installed, and many organizations do not install it, do not let a candidate install it. Therefore, what we did was we built all of that into the browser so that you don't need any installation. To use CloudX Lab or any of this, you don't need any of the installations. If you can use Gmail on your laptop, you can use CloudX Lab. So here, this is a powerful console. On this console, you can run anything. Let's say you want to do the Python programming, you can do. you want to compile your Java code, you can do, and you want to run, say, pig, you can do that by typing pig. Then you can run your Hive script by running Hive, and then it'll give you the command prompt, and then you can execute your Hive queries. Okay. If you want to interact with Hadoop, you use Hadoop jar or Hadoop FS commands. All right. So this is the prompt on which you will write your Hive queries. Say you want to run Spark, you want to interact with Spark by the way of Python. You want to execute your job, you can do that. So everything is available. If you want to submit a job for Uzi, you can do that from here. As well as from inside of you can also access all these components. You want to talk to Pig, you can open Pig from here and start writing Pig query. Similarly, you can do Hive queries. Okay. Similarly, you can do Hive queries. Similarly, you can execute almost everything. All right. All right. So this is a way of, my network is giving a problem. So again and again, it's going down. Never mind. So this is the way you interact with the CloudX Lab, and you can execute this. So this, you can see that in Hive, these are the tables created, and this table actually is storing the data in the HDFS, and you can query Hive tables from here. All right. A question from Ajay. Are you guys using chroot or something similar for security? Yes, we are using a similar kind of protection, but we are not jailing the users. So chroot is generally for, creating a virtual jail in which user can't get out, but we are not doing that. We are making it look like this cluster. We are making it look like as if in an organization when you join, there will be a Hadoop cluster already which you can use provided you are part of the same network. We're trying to emulate that. All right. So that was pretty much about the CloudX Lab. Assignments will be in the here. Okay, you can take the quiz, although you may not be able to finish more than half, but you must take it. You can take the quiz as many times you want. Akash's question is, access for CloudX Lab is for lifetime or only till the course ends? Generally, the access to the CloudX Lab is limited. If you go here, it will tell you when the if you go to CloudX Lab website, it will be automatically logged in because you have logged in into LMS. You will see the subscription ends on this date. For me, it ends on September. Okay. If you want, you can extend it. All right. Anu's question is, what system takes care of updating all the copies of data? HDFS, Hadoop Distribute. We'll discuss HDFS tomorrow. All right. So if you have to enroll for the course, you can go to No Big Data. There are around 1 or 2 seats available. I think the class is almost full. Okay. So there are only 1 or 2 seats available. You can enroll. And yeah. Okay. Next question is, there are 3 more questions. If you want to stay, you can stay. All right. A question from Subham. As we have discussed, HDFS is centralized file system and then data is distributed across multiple machines. Doesn't it bottleneck the data on the server where HDFS is installed? As every data is stored in HDFS. Let's discuss it tomorrow. That will be because this is a very valid question and we take enough time to understand this way. Okay, to understand this, I would have to go through the same kind of exercise. All right. Kanan's question is, since Hadoop is a huge data store, does it require backup storage? What happens if we lose data by natural disasters? You generally, basically, Hadoop has built in great data backup. Okay, if one machine goes down, other machine automatically comes up. Now, to avoid natural disasters like the whole data center goes down, what you do is you have some nodes on another data center in a different geography location. And her HDFS takes care of replicating data very cleverly on the another data center. A question from Samip. So after the completion of course, we will be able to apply for, yes, you will be able to clear that test certification course. All right. Okay, so that's pretty much about today's session. If you have any questions to us, feel free to drop an email to reach us at no big data. Okay. If you want to enroll, you can just straight away go to no big data and go to the course and click on enroll now and enroll. If you are only looking for lab, you can go here in the CloudX lab and just take the lab alone. Okay. The downside of the lab is it doesn't come with the course, it comes with only the few hands-on exercises. A question from Narottam regarding certification of Cloudera. So we will be providing assistance in terms of training you on various topics, and we'll make sure that we cover everything so that you are able to clear the test. A question from Samit. I have knowledge on introduction to Python in college. Will that be enough for this course? Yes, that will be more than enough. Naveen's question is, could you please share the link for recording of this session? Sure, will do. Okay. All right. So thank you very much. It was a brilliant session in the sense that I got really, really brilliant questions from all the audience. In case I have missed a question, you feel free to drop me an email at reachus at novicdata. All right. So feel free to enroll because there are around few seats available still. And this session is going to be the last one. Probably I'm not going to start the session again for maybe few months, maybe 6 months. All right. Okay, so see you tomorrow and we will continue the discussion. Bye bye. Have a good day. All right. Thank you, everyone. And I'm impressed with the questions. I totally enjoyed the session. Thank you, Pankaj. Thank you, Hari. Thank you, Ajay. Thank you, Josephine. Thank you, Pavan. Thank you, Kanan. Thank you, Robert. Thank you, Akash. Thank you, Anuj. Thank you, Ravindra. Thank you, Ravichandran. Thank you, Anil. Thank you, Hari Krishna. Thank you, Subhan. Thank you, Prudveer. Thank you, Nand Kumar. Thank you, Kalyan. Thank you, Kailan. Thank you, Akshata. Thank you, Narottam. Thank you, Naveen. Thank you, Anuj. All right. All right. I'm very happy that you liked the session. A question from Ravi is it possible to interact instead of chat? Actually, when we have the voice, um, okay. So by the way, I'm Sandeep Giri. It's just that it keeps showing that I'm Sharon. Uh, yeah. All right. Good. Good. So it'd be difficult to unmute everyone, but I can unmute on if somebody really wants to get answer. All right. Okay. Yes, Narottam. Let me check. Let me check, Narottam. All right. I'll get back to you. Bye bye. Have a good day. All right. Stay connected and